Right, so off to my left here, I have the Siglent 8357A vector network analyzer. I've calibrated this for 300 kilohertz to 4 gigahertz. The cables that I'm using are 3.5 millimeter precision connectors. I have to get that down to a BNC connector. So to do that, I go from the 3.5 down to an SMA. So these are some sacrificial adapters that I have right here that I use. So I've characterized to the end of this SMA adapter here. So we've added this additional BNC connector, which is certainly going to throw in a little bit of air. What I'd like to do is attach this to the front end of the oscilloscope here. We're going to check all 4 channels and we're going to look at the return loss. What I want to do is get a feel for how well that 50 ohm input is matched. Let's just have a look. It looks pretty good. So this is 20 dB down right at this point here, and this is at 2.77 gigahertz. Let's just see how this compares to channel 2. Again, I have all these channels set for 50 ohms, and they are currently set for 1 volt per division. It looks about the same, crosses right at the same point. Again, I don't know what adding this BNC connector is doing. Again, basically the exact same. And here's channel 4. Yeah, again, it looks the same. Let's go back to channel 1. And now let's change the input gain. So all I'm going to do is be adjusting the vertical resolution. And let's see how that affects the port match. So here's 500 millivolts. You can see that has no effect. Here is 200 millivolts. Again, no effect. Here's 100 millivolts. Oh. And you can see that's had an effect on it. So now, again, this is 20 dB in this area right here. Let's try it at the next scale up. This is 50. Here we are at 20. Here we are at 10. This is at 5 millivolts per division. This is at 2. Again, I'm sure we're saturating the front end of the oscilloscope. And this is with it set for 1 millivolt per division. Let's go ahead and we'll set this back to 100 millivolts per division. So I don't have a good way to check the roll-off of the scope. So while this Siglent VNA is going to supply a reasonably flat output, again, the fact that we have this little BNC adapter down here, that's going to come into play with this, but right now I'm sweeping up to 4 gigahertz, and you can see our waveform is basically flat. So over here I'm just going to change our stop frequency to 5 gigahertz. Oh yeah, and you can see the roll off here. It's pretty steep once we get beyond 4 gigahertz. Based on just this, I would imagine that the bandwidth that they rate this scope for is probably correct.